So your Honda's thrown you the confusing U0029 error code, and you're kind of scratching your head about where to even begin. Well, you're in the right place. We are going to demystify this infamous code together.
Oh, you know the one. You're just driving along, minding your own business, and suddenly that little D for drive just starts blinking at you. It's annoying, it's a little concerning, and it's your car's way of telling you that something important is going on.
Well, that blinking light is basically your car's way of pointing to a specific fault code it's stored in its memory, U0029. Now I know it sounds super technical, maybe a little intimidating, but stick with me. We're going to break this down step by step.
So what does U0029 actually mean? The official name is FCAN malfunction. The easiest way to think about it is like a dropped call between two really important people. Your car's main brain, the powertrain control module, or PCM, has completely lost the signal from one of its key networks. And it's not just a flicker. It's lost it for at least a full second. In car time, that's an eternity. And it's definitely long enough to set off an alarm.
All right, so to crack this case, we first need to understand the language the car is speaking. Let's start by decoding what this FCAN network really is.
The best way to picture the FCAN network is to think of it as the central nervous system for your vehicle. Seriously, it's this whole web of wires that lets all the different components talk to each other and to the main computer. So when you get a U0029 code, it's like a general distress signal. The car's just yelling, hey, the signal's out somewhere. Our job is to play detective and find out exactly where that communication broke down.
Okay, so how are we going to tackle this? We're not just going to start randomly pulling things apart. No way. We're going to use a diagnostic funnel. The whole idea is to save you time, money, and a major headache by starting with the simplest and honestly the most common checks first. First things first, we check the foundation of any electrical system: power. Is the battery healthy? Is the alternator doing its job and charging it properly? Then we just do a simple visual inspection. Are there any wires that look obviously loose, maybe a little frayed or damaged? You would be surprised how often the fix is really that simple. And look, you absolutely have to rule this out first. A weak or dying battery can send all sorts of erratic voltages through the system, and that just completely confuses the car's computers. They start throwing out these phantom codes like U0029. So before you go hunting for some complex, deep-seated problem, make sure your car has a steady, reliable source of power.
Okay, so let's say the power system checks out. Everything's solid. Now we move down our funnel and take a deeper, more focused look at those specific communication wires.
You'll often hear that the problem could be a short in the FCAN wires. Okay, but what does that actually mean when we're doing our inspection? What are we supposed to be looking for? It means we are looking for physical trouble. A short circuit happens when wires that should not be touching do. This could be because the plastic insulation has cracked from age, maybe it's been frayed from rubbing against something sharp, or it's gotten corroded from moisture. Your job is to trace these FCAN wires and look really closely for any of those little imperfections.
So what if the power is good and the wiring looks perfect? Well, we've now reached the final frontier of our diagnostic funnel, the car's computers themselves.
See, in this communication chain, there are two main control centers involved: the gauge control module and the big one, the powertrain control module, or PCM. It's totally possible that the signal breakdown isn't happening in the wires connecting them, but inside one of these modules. On one hand, you've got the gauge control module. Think of this as the brain for your instrument cluster. It's running your speedometer, your gauges, and yep, those warning lights. If it fails, it can just stop communicating. On the other hand, you have the PCM, the big boss, the main computer for the whole engine and transmission. A fault here sounds like a huge deal, but sometimes it just needs a simple software update, kind of like your smartphone. So what are the solutions at this stage? Well, it could be as simple as getting your PCM software updated at a dealership to fix known communication bugs. Or it could mean you need to replace a faulty gauge control module. And then, really only as a last resort, you might have to replace the PCM itself. All right, that was a lot to take in. Let's pull all of this together now into a clear, actionable roadmap that you can actually follow. Here is your 4-step diagnostic funnel. 1. Start with power. 2. Inspect the general connections. 3. Zoom in and examine the specific FCAN network wires. And 4. Only after you've ruled all that out do you move on to testing the computers. Just remember the rule: simple to complex, always. And here it is, your cheat sheet. On the left, you've got every potential cause we discussed, from a bad battery all the way down to a faulty PCM.
and right there on the right, the direct solution for each one. This is a perfect summary of our entire diagnostic process.
So, the most crucial point to take away from all this is simple. Don't be intimidated by a blinking light or a technical code. U0029 seems complex on the surface, but as we've just seen, it's entirely solvable when you break it down and just follow a logical, structured path.
You now have the knowledge and, more importantly, the method to investigate what your car is trying to tell you. This isn't just about fixing one code, it's about understanding the language of your vehicle. So with this new approach in your toolkit, what are you going to tackle next?